So now we're moving on to lesson 2 of chapter 9, and we're going to talk about area of triangles some more. So the learning objective part 1 is to find the area of triangles, and the second part is to use the formula for area to find the missing dimensions. So this right here, this first part of the lesson is just talking about the formula and using the formula for area of a triangle. And the second part is we use the formula and we work with that equation to solve an equation for the missing dimension. So it's just like what we did for parallelograms, but the formula is a little bit more complex for area. And then we'll have a little example on the back. So let's get started. I like this RealWorld Link today. It says biosphere. This biosphere 2 complex that's in Tucson, Arizona, researches Earth and its living systems. Sections of the building are interlocking triangles of the same size. So all these triangles are the same size. So we can say they have the same size and the same shape. It says draw the figure formed by the 2 triangles. So we have these 2 triangles over here. And look at this. If you go along the outside, it creates a large parallelogram. So this parallelogram here is what those 2 triangles created. If I did this little arrow here, it would show there's the red triangle, there's the yellow triangle. How many small triangles make up the outlined parallelogram? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So this one, 18 triangles. And how many small triangles make up each outlined triangle here? So 1, 2, 3, 4, 5, 6, 7, 8, 9 in that one. 1, 2, 3, 4, 5, 6, 7, 8, 9. So they both have 9 in each triangle. Number 4, describe the relationship between the area of one outline triangle and the area of the outline parallelogram. So look, one triangle has 9 units in it, and then this whole thing has 18. So one triangle is half of the whole parallelogram, because 9 is half of 18. One triangle is half the area of the parallelogram. Parallelogram. Draw another parallelogram like the one in the photo, separated into 2 triangles. Describe the relationship between the area of one triangle and the parallelogram. So this is the same deal, right? If you have another parallelogram, the area of a triangle is half the area of the parallelogram. So area of a triangle is half the area of a parallelogram. Wow, that's scary, but we know what it is. So that's what we learned in the Inquiry Lab 2. And now we're going to talk about what formula that gives us. So let's go to the next page and look at the formula. The area of a triangle in words. The area A of a triangle is 1/2 the product of the base B and its height H. And remember, product is the answer to a multiplication problem. So we are multiplying base times height. It's just that we only need half of base times height. Because if you turn this triangle into a parallelogram, which would look kind of like this, right? And you did base times height, it'd give you the whole parallelogram. We only need half of that area. So it's half of the base times the height. Or, and we're going to find that we want to write it like this when we're doing the second part, finding the missing dimension. Base times height divided by 2. So that divided by 2 means you're taking half of the base times the height. So you can write it both ways. This is our formula. And these two mean the same thing. So let's go to the next part. Congruent figures are figures that are the same shape and size. A parallelogram can be transformed or can be formed by two congruent triangles. So two triangles of the same size creates a parallelogram. Since congruent triangles have the same area, the area of a triangle is 1/2 of the parallelogram. It's just what we talked about up here. And just to review, the base of the triangle can be any one of the sides. The height is the perpendicular distance from the base to the opposite vertex. So if this is the base, you take the opposite vertex of the triangle, the opposite point, and you draw a line straight to the base that's perpendicular with this 90-degree angle, and that is the height. All right, so let's plug in our formula. Let's do this. Find the area of this triangle right here. Now, let's count. You can find that the measure of the base is 1, 2, 3, 4, 5, 6. And look at, we already have a perpendicular height here. So the height is 1, 2, 3, 4 units. So we're talking half of the base times the height. So half times 6 times 4. So we just, to show our work, we plug in the numbers that we know. Now it says you can use mental math to multiply this. You can think half of 6 is 3, and then 3 times 4 is 12. Or here, they did 6 times 4 is 24, and half of 24 is 12. Now, I want to talk about what if you put it into a calculator. So there are two ways you can do it. You can change half. So let's write calculator, because we're going to want to use a calculator pretty soon when our numbers aren't so easy. So the half would become 0.5 in the calculator. So you would plug in 0.5 times 6 times 4. And let's make sure we would get 12 for that. So half is 0.5 times 6 times 4, and that's 12. Now, the other way you can do it, so this is like the area is half the base times the height. Half times base times height. If you do it like this, base times height divided by 2, then you would plug it in like this. 6 times 4. So you would go 6 times 4 equals 24. And then you divide that by 2, which is 12. So on the calculator, you can do it both ways. 0.5 times the base times the height, or base times height equals divided by 2. I kind of prefer this way, just so you know, but when we do find the missing dimension, we are going to want to use this way. So it really doesn't matter which formula you use. Okay, let's look up here at the next example. Example 2. Find the area of this triangle here. So look, you have the base. This is the base. And then this perpendicular height. That's the height. So area is base times half the base times the height. Half times 12.1 times 6.4. So I just, to show my work, I plugged in the base and height numbers. And they multiplied these together first and then took half of it. So if I was going to put it into the calculator, try it with me with your calculator. 0.5 times 12.1 times 6.4, and you get that number. Now if you did it base times height, 12.1 times 6.4, and then you divide that by 2, you still get 38.72. So you can do it either way in the calculator. All right, so let's do these ones. We may or may not need a calculator. Let's see. Find the area. So this would be the base, 1, 2, 3, 4, 5, 6. And this would be the height, which is 3. So this is how we show our work. Area equals half 6 times 6 times 3. So you could do this mentally, right? Half of 6 is 3. 3 times 3 is 9. And remember, we're talking square units here. These are just units. If you plug it into the calculator, half times 6 times 3, you get 9. If you wanted to write it the other way, you would have written it like this. Area equals 6 times 3 divided by 2. So you could write it either way. 6 times 3, by the way, is 18, and 18 divided by 2 is 9. So our answer is 9 square units. Make sure that you're showing your work one of these ways. So either plug it in this way or plug it in this way, and then you can use the calculator if you want. So this one here, half of the base times the height. So area is half times the base times the height. Or you could write it, area is the base times the height divided by 2. Either way, let's plug it into the calculator. I'm going to use my preferred method. And we get 31.5. So 31.5, and we're talking square feet. So seriously, the showing your work part is really easy. One of those ways is all you had to do to show your work for that. If you wanted to, you could have done this mentally too. I would have done 9 times 7 is 63 and then thought half of 63. Okay, so moving on. We're going to find the missing dimension here. It says use the formula for area of a triangle to find the missing dimension. Now, let's just talk first about what this is going to involve. And I said we want to use this. This is going to be the easiest way because it's similar to the equations that we used in chapter 7. So let's use this equation. A equals base times height divided by 2. Now, what would be the first thing, like let's just say we were trying to figure out what the base is. We knew area, we knew height, and we know divide by 2. So the first thing we would have to do to solve this equation is we would need to get rid of the 2. Because if we're trying to get like base by itself, we need to get rid of this. So to get rid of division, to undo division, we do multiplication. So the first thing we would do is we would multiply both sides by 2. So this cancels out the 2 here, and it leaves us with 2 times the area equals base times height. So I'm going to write that first step down. So number 1, first multiply both sides by 2. So 2 times the area equals base times height. Now if we're trying to get the base by itself, then we would need to cancel out this h, and to undo multiplication we would need to divide both sides by h, and that would give us, that would cancel this out, and it would give us the base equals 2 times the area divided by height. Now what if we had 2 times the area equals base times height, same as here, but base times height, sorry that looked like base times base. But we wanted to get the height down here. So we would just divide by the base. That would undo this multiplication. And the height would be 2 times the area divided by the base. So essentially the second step is divide both sides by the unknown dimension. So this whole idea of finding the missing dimension is because of this formula right here. So it's solving the equation for the dimension that you don't know. Look at this example. They started with the equation, area equals half of the base times the height. We know that the area is 24 centimeters squared, and we know that the height is 6. So we plugged in area is 24, don't know the base, times 6 is the height, divided by 2. The first step, we had to multiply both sides by 2. So that canceled out this. Then we were left with this. This equation is 24 times 2, 48 equals base times 6. So the next step is divide both sides by, oh, this is both sides by the known dimension. Sorry, don't want unknown. Divide both sides by the known dimension so we can get base by itself here. So we're going to undo the 6 by dividing both sides by 6. And then we have the base equals 48 divided by 6, which is h. So the base is 8 centimeters. So we're going to try these two problems down here. All right, let's do this one first. We know the area, we don't know the base, we do know the height. So here's how you show your work. Do this with me. Area equals base times height divided by 2. Now plug in what we know. 40 equals base times 8 divided by 2. Now we're going to solve this equation. So I'm going to multiply both sides by 2. That's the first step. Multiply both sides by 2 cancels this out. 2 times 40 is 80. So 80 equals base times 8. The next step is divide both sides by the known dimension. So we want to get b by itself. So we're going to divide this side by 8 and this side by 8. That's going to undo this. So b equals 80 divided by 8. And that's going to mean that b equals 10. 80 divided by 8 is 10. And we're talking meters here. So the base is 10 meters. And if you want to check it, you can plug in 10. So you can say, okay, base times height, that's 8 times 10 would be 80. And 80 divided by 2 is 40. So it works. Didn't even need the calculator. All right, now let's do this one. So you start with the formula. Area equals base times height divided by 2. You plug in the known dimensions. So we know the area is 72. We know the base is 12. We don't know the height, divided by 2. Step 1, multiply both sides by 2. All right, so 72 times 2. That's 144. So 144 equals, this got canceled out, 12 times h. Now we divide both sides by the known dimension. So I want h. I'm going to cancel out and undo that 12, which means I have to divide this side by 12. Now I know that 144 divided by 12 is 12 because I just know the 12s. But if you needed to, 144 divided by 12, see, that's 12. So h equals 12 yards. I'd write it down here, but geez, there we go. I could actually fit it on, whoa, sorry, on that side. So h equals 12 yards, and if you check this, 12, so this would be 12 and 12. 12 times 12 is 144, and 144 divided by 2 is 72, so it works. So that's how you find the missing dimension. Now, there's one more little story problem right here, and we're going to do this last example together. Here we go. The front of a camping tent has the dimensions shown. So base is 5 feet, height is 3 feet. How much material was used to make this front of the tent? So let's find the area. Area equals half times base times height. Plug in what we know to show your work. Half times 5 times 3. And without using a calculator, 5 times 3 is 15. So what's half of 15? 7.5. So the front of the tent has an area of 7.5 square feet. And if you did plug that into the calculator, remember, it would be the half, 0.5, times 0.5 times 3. What did I do wrong? 0.5 times 5 times 3. 7.5. See, that's proof of why you should always do your calculations twice when you use a calculator. Or you could do the 5 times 3, which is 15, divided by 2, and that's 7.5 too. All right, time to partner up. We are going to do the guided practice. Okay, guided practice. We are going to do 1 through 5. And just like always, I want you to do one, watch, look at the answer. Do one, look at the answer. Do one, look at the answer. Make sure that you're showing your work by showing the formula and plugging the numbers into the formula. So these are just like examples 1 and 2, here and here, where we were finding the area of a triangle using the formula. All right, do number 1, go. So we have the base, 1, 2, 3, 4 units. The height, 1, 2, 3 units. Area equals half times the base times the height. If you want to write it, area equals the base times the height divided by 2. You're going to get the same answer. I'm not even going to use my calculator for this. Half of 4 is 2. 2 times 3 is 6. So this would be 6 square units. Okay, number 2. We have the base times the height. We need to take half of it. So area equals half times base times height. Or area equals base times height divided by 2. So again, I'm not even going to use a calculator. Half of 12 is 6. And 6 times 8 is 48. So this is going to be 48 what? We're talking feet. So square feet. All right, do number 3. Look at this one though. The height is this, even though it's outside of the triangle. It could have been drawn here too, but that's just kind of weird. Anyway, so go. Plug it in. You're going to want a calculator for this one. So I'm either going to write it area equals 11.25, or sorry, I probably should have done that number first. Base times height divided by 2, or you could say area equals half times base, whoa, is it gonna fit, times height, 11.25, it fit. All right, so what is it? So half times the base was 15.6 times the height was 11.25. Now let me just double check. 87.75 is what I got. Let me try it again, because calculators, you never know. This time I'm going to do base times height and divide it by 2. And I got the same thing. So 87.75, and we're talking square meters here. So now, number 4 is like example 3. So what was example 3 again? Oh, finding the missing dimension. So first you plug in what you know, multiply both sides by 2, divide both sides by the known dimension. So, Ch9 designs uniquely shaped ceramic floor tiles. What is the base of the tile shown? Here's the area, here's the height. Plug it in and find the base. Go ahead and do it. All right, I'm going to do it, let's see. I'm going to do it over here. So I know area equals, I want to use base times height divided by 2. We know the area is 21. We don't know the base. We know the height is 6. Step 1, multiply both sides by 2. So I'm solving this equation. Multiply both sides by 2. That undoes the divided by 2. So now 2 times 21 is 42. Base times 6. So now I need to divide both sides by the known dimension to get b by itself. So divide this side by 6, undoes that. Divide this side by 6. So now I have b equals 42 divided by 6, and that's 7. Didn't even have to use a calculator. So I can check it like this though. It should be 7 times 6 divided by 2 equals 21. So 7 times 6 divided by 2 is 21. That works. And we're talking inches. So the base is 7? Yeah, 7 inches. Okay, now number 5 is just like number 4. So you got a real life situation and you're finding the area of a triangle. Consuela made a triangular paper box as shown. What is the area of the top of the box? So look here. The base is 10. The height is 9. Plug it in to the formula and then check your work. So area equals half times the base times the height. Or you could write it area equals the base times the height divided by 2. So it would be 90 divided by 2, or half of 10 is 5 times 9. Either way, that's 45. So the area is 45 centimeters squared. All right, I think you're ready for the independent practice, and I want you to do this on your own. For the independent practice today, you are doing 1 through 6. So 1, 2, and 3, you're just plugging in the numbers into the formula. Make sure you show your work by doing that. And it's just like examples 1 and 2. Number 4 and 5, you're finding the missing dimension, just like example 3. So you're going to be showing your work like this. And then number 6, it's just like example 4. So you have this real life situation of this section of a house and you're finding the area. So show your work by plugging into one of those formulas. Go for it. All right, let's take a look at how to do these. So you can either put in half times 6 times 8, base times height, or 6 times 8 divided by 2, and then you get 24 square units. Here in the calculator, I did half times 24.8 times 16, or you can do 24.8 times 16 divided by 2, and you get 198.4. Here I plugged into the calculator, we had 41.5, so I wrote it 41.5 times the height divided by 2, or half times 41.5 times 36. So either way, you get 747 square feet. For number 4, area equals base times height divided by 2. So I plugged in the area as 245, base times 14 for the height divided by 2. I undid the 2 by multiplying each side by 2, so 490 equals b times 14, divided both sides by the known dimension. That gave me b equals 35 inches. Here I started out with the formula. I plugged in this for area and this for base, and then I multiplied both sides by 2, and 256.5 times 2 is 513. That equaled 27 times h. Divided both sides by 27. 513 divided by 27 was 19 centimeters for the height. And then to find the area of this triangle right here, you can either do half times 7 times 4 or 7 times 4 divided by 2. Either way, you get 14 square yards. And now it is time for the reflection. So for the reflection, we're going to find the area of triangles and we're going to use the formula to find missing dimensions. For number 1, you're using words here. To find the area of a triangle, we have to take half of the base times the height, because why? Why is that the formula? You can draw a picture to go along with your words if you want. Make sure you use complete sentences, and just a reminder, you're relating it to area of a parallelogram. Then the formula, if area is A, B is base, H is height, what are 2 ways to write the area of a triangle? So what are the 2 formulas? Label the base and height on this triangle. Find the area of these triangles. And to show your work, you need to show the formula, and you can use a calculator. And don't forget to say what the units are. Then on the back, if you know the area and the base of a triangle, you find the height by, what do you do to both sides first? And then what do you do to both sides second? If you know the area and the height of a triangle, you find the base by, what do you do to both sides first? Then what do you do to both sides second? Find the missing dimension down here for these two. And to show your calculation, you need to show your work. So show how you set up the equation and how you solved it. You can use a calculator if you want. When you show your work for those, it should look like this right here. Okay.